Hi, so in this we will discuss LeetCode problem 3016 minimum number of pushes to type word to. So you are given a string word containing lowercase English letters mean A to Z, right? So telephone keypads have keys mapped with distinct collection of lowercase English letters which can be used to form words by pushing them. For example, the key to is mapped with A, B, C. So we need to push the key one time to type A and two times to type B and three times to type C. Okay. It is allowed to remap the keys numbered 2 to 9 to distinct collection letters. The keys can be remapped to any amount of letters, but each letter must be mapped to exactly one key. You need to find the minimum number of times the keys will be pushed to type the string word. So I have to minimize the number of pushes, right, to type the input string. So return the minimum number of pushes needed to type the word after remapping the keys. Okay, so suppose for this example, so here actually 2 is mapped with A, F and G, right, and 3 is mapped with B, H and I. Okay, in this way actually all 2 to 9 are mapped. Okay, suppose I want to actually string is like AFG. Suppose the input string is AFG. So how many actually pushes needs here? For A I need here 1, for F I need 2, for G I need 3. So total how many actually pushes needed? 3, 6, right? So I have to actually minimize this. So how can actually minimize the number of pushes? Like here actually you can actually on observation actually you can check for this. Suppose our for this map our input string is suppose Z, and suppose the input string is suppose A, B, C, then D, 3 times D, 2 times A, B time 1 times B and C time 1 times C and 3 times D, 2, 1, 1, 3. So if I want to minimize the number of pushes, then like I know that I have to print D at least 3 times I have to print, but how many strokes need to go to the actually D? Suppose our map is like for 2, I actually map with A, B, C and D, suppose. Okay, so for A how many stroke needed? 1. For B stroke needed 2. For C I need actually 3 strokes. For D I need 4. So here actually for this if I did this mapping, like A is mapped A, B, C, D is mapped with 2. So to type actually A I need actually 2 times I have to type A, and to type A how many stroke are needed? 1, right? This is for A. For B I have to print 1, and to type 1B how many stroke are needed? 2. So this actually multiplied by 2. So this actually total number of pushes for to print B, right? Now for C, how many C are there? 1. To print C how many strokes I need? 3. For 1 C I need 3 strokes. So total 1 into 3. So for this is for C. And for D how many D are there? 3 D are there. So for each D how many actually strokes are needed? 4, right? So how many in this actually you got the answer, right? So here actually this is actually what is the value? Number of total pushes 2 plus 2 plus 3 plus 12. So this actually 2 plus 4 7, 7 19, right? Suppose if I map this in this way, like same 2 is mapped to it, suppose D, then A, then B, then C. Okay, then how many actually pushes are needed? For the input string A, B, C, then triple D, right? So for A how many are there? 2, and 2 here actually for D strokes are 1, for A strokes are 2, for B strokes is 3, and for C strokes is 4, right? So for A, how many actually strokes are needed? 2. So 2 into 2, because there are 2A, and for each one A I have to stroke push 2 times. This is for A. For B is 1 times it present, and for 1B I need 3 pushes. So this is for B. Now for C, how many C are there? 1 C are there, and for 1 C I 4 pushes are needed. Okay, so this is for C. And for D, how many D are there? 3 D are there, and for each D strokes is 1, right? So this is for D. So what is the total number of pushes? 4 plus 3 plus 4 plus 3. So what is actually total value, total number of pushes? 7, 14. So this is actually less than 19, right? So in this actually I can actually minimize. How actually you are minimizing this? So which character is present maximum number of times, place that character at the front. Front means, like, I know there are options are 2, 3, 4, 5, 6, 7, 8, then 9, right? Here actually they have mentioned 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 2 to 9 actually I can map actually, right? So here actually I can, this is our actually mapping table, right? So for 2 I can place what? I will place what is the maximum number of character it's present. So first of all, suppose the mapping X has suppose 10 times, Y has suppose 9 times, Z have suppose 8 times, A have 10 times. Okay, so X I will present here first time. Okay, then A I will present here, then Y I will placed here, and Z will be placed. In this actually what will happen? For X also I need 1 stroke, for Y also I need only 1 stroke, for Z also I need 1 stroke, for A also I need 1 stroke only, right? So in this actually I am actually placing at the first position of each character, right? So what will happen? I can actually place like they are actually each character have a box. Okay, so for first place I need actually 1 stroke, right? For each character, for each number. So I placed a number which actually present maximum times. So suppose I will place here A, then I will place here B, then I will C, in this way. Then till 9 actually I can place 8 character for 1 stroke, by using 1 stroke. Then for next 8 character I need 2 stroke. So I will actually try to distribute each character equally. So in this actually I can actually minimize the number of strokes. So first 8 character, whichever actually the present maximum times, I will place all those into the first place of 8 numbers, 2 to 9. So there are actually 8 number, 2 to 9. Next 8 character will be placed at the second place of each number, right? Then the next 8 character, whichever actually frequency is the next 8, that will be placed in third place. Okay, then next 8 character, if it is present, I will place it at the 4th place. In this actually I can actually, like, whichever actually the present maximum times, suppose X, Y, Z, if I multiply this with 1, this will actually or minimize the total number of pushes. So if our sum 1 is our total number of pushes needed, if I want to minimize this, then I have to minimize the number which are actually maximum frequency is constant, because I can't change the frequency of each character, it is constant, but I can change the strokes or pushes for each character. How can I actually minimize this? I will place that at the front as early as possible. Got it? So let's go to the actual code actually. So suppose first of all check this example A, B, C, D, E. So I have actually 9, 2, 3, 4, 5, 6, 7, 8, 9. So A I will place here, B I will place here, C I will place here, D I will place here, E will place here. So each character stroke is 1. So there are 5 characters, so 5 into 1, so this is actually our minimum number of pushes needed 5. That's why the answer is 5. Got it? So let's go to the actual code actually. So I have taken a map. So first of all, count the frequency of each character, because I want to store the place the character, map the character with respect to the frequency, which are actually the highest frequency. I will place it at the front of each number, right? That's why I will like for A I will check how many actually it's present. For B, in this actually for till Z I will count this. Okay, now I have taken a priority queue max heap. So it will actually store taken a input is a type is pair integer and character. Why integer? Integer is the frequency of each character, and what is the character? The frequency it have. So I am just iterating the map. I am just inserting the frequency. This is the frequency, and this is the character. Like for A, I will check what is the frequency. So this max heap or priority queue can actually sort this according to the frequency of character, right? So this is max heap. So maximum value, which character has the maximum frequency, this will come at the first, right? So our answer is initially 0 and the current is 1. Current 1 means I can actually place maximum 8 character at the front. At the front means the first place. Then for the next 8 character will be placed to the second place, right? So that's why currently this is the first time I were counting. Okay, so till our priority queue is not empty, so I'll check if it is the first 8 character. So first 8 character means what? Our stroke will be 1, right? So that's why initially answer will be answer plus priority queue top the whichever the frequency it have, actually frequency into stroke. So priority queue answer into this is into 1 is not actually matters, doesn't matter. That's why we just whatever the frequency we are adding into the answer, means the pushes we need. And also the we have placed this, that's why we have already taken this character into the first place, so that's why current plus plus. Okay, in this actually I will placed all the first place of 8 numbers 2 to 9. Now for next 8 means 8 9 to 16 I will place the at the second place of each number. So that's why I will check whatever the frequency it have into 2, because currently number of pushes for each character will be 2, and we have just whatever we are placing anything, we are just increasing the count and current plus plus. And for the next 17 to 14, right, here actually strokes will be 3 for each character, because we are placing all character into the third place and the frequency also less. So that's why we are just whatever the frequency it have, the current character, and into it multiply with 3. Okay, and also current plus plus. Got it? Else like 25 to 26, because maximum 26 character can present. So whatever the frequency it have, that character into 4. Got it? And add it into the answer. And also for each character I will pop this from the priority queue also. Got it? And at the end return the answer. Okay, understood the logic? Like first 8 character will be placed at the first place, then next like 1 to 8 will be placed at the first place, then 19 to 16 will be placed at the second place, then 17 to 24 will be placed at third place, and 25 to 26 will be placed at the fourth place. And how we are deciding which will be placed at the first place? By using the frequency. Whichever the frequency is more, I will place this, try to place this into the front, right? So what is time velocity of this algorithm? So time velocity, like you are iterating this, so big of n, you are iterating each character. So if the word length is n, so our time velocity will be big of n for this. Here also we are for each character this is 26 maximum, right? Maximum 26 character, different character can present. Here actually you are just popping this, so 26 n log n, 26 log 26, right? Maximum. So here actually time velocity will be big of n for this, and here actually it is constant big of 26. Here also maximum priority queue size will be maximum 26. Got it? So time loss value 26 big of n, because length, word length can be different maximum, but the priority queue size will be maximum 26, because maximum 26 character can be present, right? Got the logic, right? Thank you.